Good afternoon and welcome to Calculus in the PM. I'm your host, Mr. Shindelka. It's a beautiful sunny day outside in Regina. Traffic is moving along steady as expected, and temperature right now is 16 degrees, wind speeds of 22 northwesterly wind. Before we begin our lesson today, I'd like to bring you a message from our sponsor, Papa Joe's Farm Fresh Organic Eggs. Quality guaranteed from a name you can trust for over 40 times 10 to the minus 3 years. Papa Joe, that's me. Our egg buyers examine each egg carefully so that we deliver nature's Kinder Surprise to you every time. See, 40 years ago, that's my dad actually. We're getting eggs from the Hutterites and stuff like this. Anyways, that's me with my signature. Feel free to call me Papa. Hey, Papa Joe. How do you do that? We are continuing from yesterday, limits of infinity, and we just took a look at yesterday's problems, a couple of them. Asymptotes is what you find often. With radicals, though, it gets a little confusing at times. So we're going to start with a basic fact. Just like with the others, you know, we had one basic fact and we applied this idea throughout problems. Yesterday, the basic rule that you really need to know out of these things is that 1 over x, if you do that limit to infinity, you're squeezing it down to 0, right? Here, one thing that we're going to use over and over again. It may have been mentioned before. You guys are distracted, aren't you?
I can't see.
You can't see? Sure, I'll just pause for a second. Seems like it's a silly thing to do, but we have to remember this. Square root of something squared is equal to the absolute value of x. This is where you're solving an equation, right? Now just think of this. If this was, why does this work this way is really what I'm going to ask us. Because you might be saying, this seems stupid. So if I said, what's the square root of 4 squared? And you'd say it is 4. Now, I'm going to give this, though. What is the square root of negative 4 squared? Like, you're not really going to square it out and say 16 and then square root. But you'd say it's 4 as well, right? Because that's what you get if you got 16 to the square root. This absolute value, though, if you didn't know what x was, so think of it this way. If you don't know what the x is, say it was negative 4, the answer isn't equal to x, it's equal to the absolute value of x. And that's just because this number here could have been a negative number squared. You follow me on this logic? It seems silly because when you have numbers, you don't need to think that way. And this is an example here where if x was negative 4, you'd get some goofy answers if you just plain old said the square root of this x squared with just plain old x. You'd get something that's wrong. Okay, and we know the square absolute values, you know, positives. If it's negative, switch the sign. That's what that is. Okay, we've got to use that idea. So limits of infinity. So the limit of x approaching infinity. This radical expression divided by x minus 2. Now I'm giving you some hints here. X squared is factored out to provide one of these absolute value reductions here. So what do I mean by that? Well, let's take this slower. Take everything slower. Okay, I want to make sure I'm recording because Corey and the gang need to see this EJ. Okay. X squared is factored out under the radical sign, under the square root. So right now, if you get good at this, you can do it a couple steps at once. I'm going to factor out x squared. Let's see what I've got left behind. This is not intuitively what you would think of doing. This is a method you got to learn. So I'm snatching the x squared out of this. That's 1, right? But then 3x you're taking out x squared, so you've got 3 over x. Just think divide by x squared. This is something, though, you probably already recognize from what we did yesterday. That's something we can deal with those infinity things, right? 3 over x as it approaches infinity is really 0. Okay, back to this. I haven't done squat to the denominator. But now I can treat this like one of the other problems. What do we do? Multiply when you got expressions on top and bottom, and they're not sines or something like or cosine or something. You take the highest degree, and in this case, x is x to the 1. It's not, but if there's x squared or x cubed on the denominator, you'd multiply by 1 over x cubed or 1 over x squared. We're going to multiply top and bottom by 1 over x this time. So this is how we're choosing it here. I'm going to go 1 over x here, 1 over x here. And that's sort of like yesterday, right? You guys recognize that? I hope. Can you see that? You guys are that good? Okay, good. Now, I'm kind of doing 2 steps at once, I realize. I apologize. We also have to do, and this is why I'm like, oh, I shouldn't have started this. You guys can have it. X squared is factored out. I just did this. To provide an x squared is equal to the absolute value reduction. Now, think of it this way. This part of it, there, I can do the square root of x squared, right? It's equal to the absolute value of x, we said. The other stuff will be left behind and still under the radical. This is no different than when you, and I'll just do this and erase this. Is this different than when you get the square root of 12 is equal to 4 times 3, right? And you'd say, well, the square root of 4 is 2. Leave the 3 behind. You guys have done stuff like that. This is just more abstract because it's x's. You guys see this as being the same thing? And we now have to consider the sign. This x squared, well, we're considering x when it's approaching positive infinity, so you're guaranteed that if it was a billion squared, it's going to be positive when it comes out, right? So there's no worries about a sign, S-I-G-N error. So because it's approaching positive infinity, this reduction, when I take that out, x squared, is going to be plain old x. So I'm going to use the limit notation, keeping that because I haven't evaluated x. Because the absolute value of a positive number is just itself, just x. Radical, 1 plus 3 over x over. Now, I purposefully left a little space here, but I wanted to put some more. Remember how we have this 1 over x? I did that in green at the same time. I kind of started ahead. I normally would do everything else, but I'm trying to teach you guys. This 1 over x still we're thinking about too. To multiply that through, I'm not going to leave it here. Where does it make more sense to put this? Don't push it into the radical. Okay, so that's there. I think you see what happens with that. Next, the bottom turns into, well, 1 over x times x, and then 1 over x times minus 2. So 1 subtract 2 over x. Okay, yeah. And I said, basically, this is what we were doing earlier. Think about what absolute value of x means as x approaches positive. And I bold letters. I'm shouting, positive infinity, right? It's going to be a positive answer. It's going to be the same sign. So that's why I have that there. We've taken care of it. Next. So our next step is, I'm going to apply the limit to the fractions, reduce them to 0. Well, okay, I'm going to rewrite this. infinity, 1, positive. I'll re-emphasize this. This is positive 1. We could actually just jump to the answer, but I'm trying to instruct you guys too. So I don't want to leave anyone out. Okay. Apply the limit to the fractions, reduce them to 0. Remember, you can't plug in infinity. So you're just going to jump straight to it. You're going to say, well, a constant doesn't change. 1 is 1. The square root part will be 1 plus 0. I guess I'll write this out. So 1 in front, okay. 1 plus the 3 over a really large number is 0. 1 minus 0. I think the arithmetic part of it is fine. Right? 1 square root. Oh, yeah. That's all. I gotta re-emphasize, you don't need the positive sign. It's assumed positive, but it comes out to be positive. So if you graph that, that means the asymptote would be positive. Yeah.
Can write like that.
What's that?
Can you write it like that without the limit x to the infinity?
Can I write this step here?
The x equal to after infinity.
Here.
Yeah.
Okay, what about this step?
Can you just write it without limit x to the infinity?
Oh, why did I drop the limit part here? Because I'm evaluating. Once I'm evaluating and I no longer have variables in here,
Yeah, you can take it.
that you must take it out. Yeah, for correct notation. Yeah. Never drop before, if you still have your x's or whatever x is approaching, in this case, whatever variable is approaching, until you've considered that, though, you have to have the limit notation there. Once you do it, though, drop it. Okay. Hey, look at this, same question, except negative infinity. Now, so the front work is pretty much the same. Limit x approaching negative infinity. So we'll take it a little quicker. I'm going to do the factoring under the root. X squared's pulled out. Because I can pull out squares out of a square root. 1 plus 3 over x. This time I'm not going to introduce those 1 over x's until the next time. I want to solely concentrate on the square root part. Philosophically, you got to think this is different. Here we're talking about x approaching really negative numbers, really large negative numbers. Negative 1 million, negative 1 billion, etc. Bigger, more negative and more negative as smaller and smaller, you can say. Anyways, when I take this out in front of the radical, I'm going to leave it up because we know what we're doing with this. Now, I'm thinking absolute value, right? The absolute value of it, but we know it's going to be of a negative number, negative 1 billion. So what do you do to get that? You change the sign. Whatever that was, put that in there. Now, do you guys get the idea? Because we know that, I don't know exactly what the number is, because infinity is not a number, and negative infinity is, but I know that it has a negative sign. And this would be like saying, well, I know it was back up here. If it was negative 4 in that square, that was my x, I know that I'd have to take the opposite sign to get it, to complete the absolute value. Double negatives, and you come out in the wash there. Now, the rest of the stuff, 1 plus 3 over x. Let's move this down here. There, we grab that. X minus 2. Now this time, this is the way we should have considered it before. I was trying to do too much at once. 1 over x. 1 over x. What's that?
Why did you have negative x?
Where?
Because,
Okay, which one? The one in front?
yeah,
That's what we were just going through?
I didn't want
Okay, yeah. I'll re-explain this one then. Okay, we're approaching negative infinity, so you're guaranteed the x, if you chose negative 1 million, squared it, took the square root, and you said it's just plain old x, you're gonna get negative million out of it. But we know that it has to be a positive. Since the x, like this step here, right? When it's popped out, you can't just say it's plain old x, because you would be saying that's this negative, x would happen to be negative 1 million or negative 1 billion, and that's impossible to come out of a square root. So it's not just the x, it's the x with the opposite sign.
It's supposed to make sense.
It would make it positive if you actually put in a number. Now remember, this is abstract thinking, but infinity is not a number. If you're approaching negative infinity, make it negative if you want a simple explanation, or it's not simple, but quick explanation. But I'd really prefer that you sort of understand it philosophically, because then it isn't memorizing. Anyways, it turns into the same stuff as before here. I'll just read it, except for the sign difference. So negative x over x is negative 1 here. On the bottom, 1 minus 2 over x. We can apply, plug in negative infinity, we get 0. So 1 plus 0 on the, under the root. 1 minus 0 on the denominator, we get negative 1 overall. Now, in the first example, I showed more arithmetic than I normally would, because I'm trying to show you guys how to do some things, right? Now, what do we want to do? I'll just hang on. Is there any questions about this? I'll give you a chance to do some practice. As a matter of fact, these questions are what you're going to practice. Oh, just a second here. Is that one a screwy one? Yeah, I'll tell you what. Just for time reasons, there's nothing wrong with this one. This stuff's out. I can tell what the answer is already.
Want to see the ones in the bottom?
What's that?
Like the ones written out there?
Yep, you do. Of course, we skipped 17 from the first part of the assignment, right? In the textbook. But everything else, 46, 7, 8, 50. Do those. We'll pause.